This lesson is 8.7, writing a polynomial equation. So our goal today is to write a polynomial equation given a graph or the polynomial zeros. So before we were given a polynomial function, we were asked to find the zeros. Now we're going backwards. We're given that a function has these zeros, we want to write an equation. So we have to do a little bit of backwards thinking. So we know that x equals 2 and x equals negative 3. So we need to write a function given these zeros. So we would have f of x equals, well, since we have two zeros, we have to have two factors. So we have x and x. So we want to think, well, how did we get to 2? How did we get to negative 3? Well, we set these factors equal to 0, and we solved. So if we go backwards, this has to be x minus 2, and this has to be x plus 3, because if we add over 2, that's how we get x equals 2, and if we were to subtract over 3, that's how we get x equals negative 3. So this would be our possible equation given these zeros. So I'd like you to pause the video and try the next two examples. Given those zeros, write a possible equation and then play the video for the answer. So for the second one, we can use any variable we want for this function. If we wanted to use p of x, we could use p of x equals, we have 3 zeros, so we should have 3 factors. So we have x, x, and x. If we have negative 1, this factor should be plus 1. Positive 5 should be minus 5. And then positive 8 should be minus 8. For our third example here, choose any variable. We have g of x here equals, now we have 3 zeros, so if we were to put our 3 factors, we would have x plus 2, x plus 2, and x minus 4. Now we can see here that these two factors are the same. So since these two are the same, we have a multiplicity of 2. So we can go ahead and simplify this to x plus 2 squared times x minus 4. And this is what we would want our final equation here to look like. Now we could also be given something like this that says x equals 4 and x equals negative 2 with a multiplicity of 2. And if we're told that it has a multiplicity of 2, we would still end up with the same equation. If we have a multiplicity of 2, it just means we have that 0 twice, so we have 2 of those. Now we want to write a possible equation for the polynomials graphed below. So first we need to identify, well, what are the zeros? So in this unit, we're only dealing with real zeros. So we know that based on our shape of our graph, we should be able to identify how many zeros we're going to have. So this is first one here is a cubic. So it's of degree 3, so I know I should have 3 zeros. And in my equation, I should have 3 factors. So if I identify what those are, here is my first 0, and that's at x equals negative 4. Here I have a 0 at x equals negative 1, and here I have a 0 at x equals 2. So now that I have identified my zeros, I can go ahead and write my function just like I did on the previous examples. So I would have f of x equals, it is a cubic of degree 3, so that tells me that I need to have 3 factors, which I identified. So I should have f of x equals x plus 4, x plus 1, and x minus 2. Once I identify what all of my factors are going to be, the only other thing I need to account for is this going to be a positive or a negative function? So since it is ending positive, I know it's positive and I don't need to add a negative out in front. So this would be my final function. For my next graph here, I can see that I have a quartic, something of degree 4, so I should have 4 zeros. So if I go ahead and identify what those are, I have x equals negative 3. I have x equals, here I'm at about negative 1.5. And I'm going to want to write that as a fraction. So that's going to be negative 3/2. I have x equals 1 and x equals 4. So I have 4 zeros and I have a polynomial that is of degree 4. So if I want to go ahead and write this, let's call this g of x. I have x plus 3. I'm going to skip this factor for a moment. I have x minus 1 and x minus 4. Now this factor here is a fraction, so I have negative 3/2. So I know that when I found this zero, I had x plus or minus equals 0. Now, since this is negative, I know this has to be positive because I had to subtract over. But I'm going to have a number out in front of my x because I did divide. So if I went in reverse, I would have 2x plus 3. And if I were to solve this, I would subtract over 3 and get 2x equals negative 3 and then divide by 2. So my x equals negative 3/2. So I can see that down here I would need to have a 2x plus 3. So we're doing backwards thinking here. Now the last thing I need to account for is this a positive or negative function? So since I am ending negative, my arrow's going down, I have a negative function, which means I need to place a negative out in front here. So my function would be g of x equals negative x plus 3 times 2x plus 3 times x minus 1 times x minus 4. The last thing we're going to look at is what about these? Write a possible equation for the polynomial in factored form. So here I have double roots. I have something with a multiplicity because it's tangent to the axis here, or it bounces off. So as I come down, I don't go through my axis, I bounce off my axis and come back up. So this indicates that I have a double root. And on this first one, I actually have a double root at -1 and at 2. And when I go ahead and write what my zeros are, so I identify my zeros, I'm at x equals -1 and x equals 2. Well, I only have 2 zeros, but I have something that is of degree 4, and I know I need to have 4 zeros. So I should be able to tell, well, these are a double root, they bounce off, and it accounts for my 2 other zeros. So if I were to write this out, I have f of x equals x plus 1, and since it is a double root, I have 2 of them. I have another x plus 1, and then I have 2x minus 2's. Since I have 2 of them, I can go ahead and simplify down to f of x equals x plus 1 squared times x minus 2 squared. showing now that I do in fact have 4 zeros because I have 2 double roots. This is also a positive degree 4 polynomial, so I don't need to account for a negative. So for my second one here, if I go ahead and sketch this, I can see that I have 2 distinct zeros on my x-axis. So if I identify those, I have x equals 2 and x equals -1. However, I can see that this 0 here is a double root. It has multiplicity of 2 because it bounces off the x-axis. It's tangent to the x-axis. So that means there's 2 zeros of x equals 1. So if I go ahead and write my function, I have g of x equals, well, there's 2 x minus 1s and 1 x minus 2s. These are plus 1s, sorry about that. So I have 2 x plus 1s and 1 x minus 2. And it is of degree 3, it's a cubic, so I should have 3 zeros. If I were to go ahead and simplify this, I have g of x equals x plus 1 squared times x minus 2. Then I need to make sure to check to see if it's negative or positive, and my function ends going down, so it is a negative. So I need to make sure that I have a negative out in front. So I have g of x equals negative x plus 1 squared times x minus 2. So always make sure to pay attention to what degree the polynomial is, so you know how many zeros that you should have, so that we're paying attention for those double roots, those multiplicities of 2.